You see the classification of microwave tubes, uh, li- especially linear beam tubes or rotor tubes, and these are cavity type and slow wave structures. In the cavity type, under resonant, two amplifiers, structures are there, two tubes are there. One is a two cavity klystron amplifier and a reflex klystron oscillator. And now see the two cavity klystron amplifier. So here, this is the two cavity klystron amplifier schematic diagram. First, we start with a cathode, and a filament is there, which is heated. Because of this filament heating, a cathode will emit the electrons with the principle of thermionic emission, and apply with the negative voltage to the cathode. The cathode will emit the electrons with thermionic emission, and these emitted electrons are focused by the focusing electrodes, and they are focused towards the catcher cavity. Here, two important cavities are there. One is a buncher cavity, or also called as input cavity, and second one is a catcher cavity or output cavity. So because of these two cavities only, it is also called as a two cavity klystron amplifier. Here, when coming to this input cavity or buncher cavity, a small RF signal is given to this probe or coaxial loop, and these electrons and the RF signal will interact in this gap or gap A, or also called as gap A or buncher cavity. After the interaction, the bunches will form, and these bunches, in the place of drift space, these bunches will make an amplification, and the principle of this amplification process is called as a velocity modulation. So this amplified signal is captured by this RF output or catcher cavity, and you can get our output as a amplified output structure, amplified output signal. So now this is the 3D cross-sectional diagram of, diagram of a two cavity klystron amplifier. And here is RF input and here is RF output, and two cavities. One is input cavity, buncher cavity, and output cavity or catcher cavity, and a cathode and a filament. And these are the accelerating nodes or accelerating grid or focusing electrodes. Now see, the principle of working of this velocity modulation of two cavity klystron. And the two cavity klystron, if you see that the velocity of the carrier is going to increase, automatically the current I is also increased. Why? Because the instantaneous current I equal to dq by dt. Nothing but the current is proportional with the rate of change of charges q, that is a dq by dt. So here the charge is electron. So if the velocity of electron increases, that is a dq by dt, or q is the velocity of electron is increases, automatically the current I increases, and this is a relation of velocity of charges and currents. So so here the velocity modulation is the process to increase the velocity of electron beam or electron or a charge, and that will amplify the current, that will increase the current, that will amplify the signal, and that is called as velocity modulation. Or velocity of the current, velocity of the charges are going to increase, that will increase the current. Why? Because I equal to dq by dt, then the amplification is going takes place, and this is a velocity modulation. And increasing the velocity of a charge increase the current I. Why? Because I equal to dq by dt. So here now see the how the velocity of electron is increasing, and you can call as a bunching. So here observe this. We can take an example of three important electrons or charges. One is a x, one y, and z. The x is a one delayed electron, and y is a reference electron. Z is a early electron, late electron, and reference electron. X is the early electron, Y is the reference electron, Z is the late electron. For example, take an X. So early electron, and this X electron is interact with the RF field at a buncher gap or buncher cavity, which is in the negative side. So if the electron interacting with the negative RF signal, the electron is negative charge, here is a negative electron. So a, a repulsion is there. So that will, a repulsion force is there that will decrease the velocity of this X electron. Means the electron X is decelerated. And coming to the Y electron, and this Y electron is interacting with RF signal at a zero voltage. So there is no change in the velocity of this Y electron or Y electron charge, and therefore there is no change in the velocity in the Y electron. Coming to the Z electron, and this Z electron is interact with the positive signal of this RF signal, and the positive signal will attract this electron, negative electron. So therefore, there is accelerating in the movement of electron. So one is decelerating, one is no change in the velocity, one is accelerating. These three electrons are mutually share their velocities at the name of called as a bunching. Once the bunch is formed, they mutually share their velocities, and the resultant velocity of these electrons are going to increase. Resultant velocity of these XYZ electrons are going to increase. Why? Because they are coming to the rest called as a bunch. And while coming to the rest, these three electrons will share, mutually share their velocities, and therefore there is a velocity modulation is existing. And this velocity modulation after bunching will create a increase in the current in the tube in the amplifier. And why? Because I'm initially saying that I equal to dq by dt. Here the velocity of electrons are going to change because of the bunching. Automatically, the current I is amplified. This is a principle of working of two cavity Klystron amplifier. So here you can observe this. In this case, in this slide, we have to see that how this, what is the space, how many bunches we are making in this drift space, how much drift space, how it affecting this cathode, affecting the modulation of the signal amplification system. This will be discussed in the next class.